All righty, let's get going. Thank you so much for joining us today again. I know that this is time out of your day, and we're really excited to talk to you about zero waste, high throughput manufacturing with QLS. Today with us is John Calhoun, our Director of QLS Business Development, and he'll be presenting all the slides today. Before we get started, just wanted to cover a few housekeeping items. First and foremost, we have two options for communication. We have Q&A and chat. We'll be answering all questions at the end of the presentation. So if you have anything that you want to enter in as you go throughout the presentation, please just do so, and we'll address as many questions as we can during the Q&A portion, and we'll follow up afterwards with any questions we weren't able to answer live. If you run into any immediate technical issues, please feel free to utilize the chat function. So if you have any trouble with audio, video, delays, anything like that, feel free to communicate it there. My first recommendation is always, if you have to, you can always leave the webinar and rejoin, and a lot of times that will fix any audio or video issues you might have. And with that, I'm going to turn it over to John and get us started.
Hi, everyone. Welcome to the Zero Waste High Throughput Manufacturing with QLS webinar. My name is John Calhoun. I'm the Director of Business Development for Nexa 3D. And today I want to take you through our Nexa 3D factory. This is a factory that has really three vectors to work along. One is a wide range of materials. Second is your ability to scale at interval your production, and also to work in a sustainable environment. So with that said, let's get started. If we look at what the industry experts are saying about additive manufacturing with powder-based polymers and metals, they expect it to grow to $5 billion by 2029. And if we think about that logically, a big part of that is going to be operating with minimal waste. Not just because minimizing waste and operating sustainably is great for the environment, it's also profitable to do so. And I think Nexa 3D is the only offering in the market that allows you to be more profitable and work in a sustainable environment as well. So with that said, let's get into it. And I want to explain what I mean by this slide of the Nexa 3D Parametric Factory. What this means in plain English is it really just allows you as a customer to start at any point with our lowest cost offering like the QLS 230, or start with the 820 and several material carts. And it allows you to implement a phased material scaling approach, meaning that all of these machines can run either plastic or metal parts for production, and allow you to work in a zero waste environment with plastic and metals. And so this allows you to also scale the production as well by adding additional machines or adding additional carts. And the really nice factor that we have here is the ability to work with your staff. So with fast cycle sintering on the 236 and 230, we operate on a 24-hour cycle time. This is going to make sure you have the most possible productivity interaction with your staff. No one is benefiting if the machine is completed printing and just sitting for hours waiting for someone to show up. So the ability to trigger these builds and complete them in a 24-hour timeline is what we mean by fast cycle open platform sintering. And of course, doing that with zero waste. With the 820, as you'll see as we go through this, we have the ability with it to do 3 complete builds per day. And then also to bring in the capability for automated guided vehicles to move the carts in and out. And you really have a optimized lights out production environment. And the Nexa software is going to provide real-time analysis of your productivity, and you can look at that data across several different metrics, right? You can look at the materials You can also look at build density. You can look at any particular day in the history of you running the machine to see what those factors were on that specific day. So it allows you all the tools you need from a productivity standpoint to monitor and make sure you're making the most of your equipment. So digging into these a little bit deeper, the 820 is capable of doing up to 8 liters per hour at 20% dense builds. That's unparalleled in our industry for selective laser sintering or fusing technologies like MJF. No one can match that kind of output. And so at 350 by 350 by 400, with 400-watt lasers working together, you're really looking at 3 complete builds that are very heavily packed at 20% dense output daily. So again, this is an open platform machine. We talked about the comprehensive data dashboard, but the real key here is I've got 20 materials to choose from, and then I can easily swap the materials via the material carts that you see on the screen. And these systems start from about 550,000. So looking at the 236, this is the first of our 2 smaller platform machines. The 236 has a build volume of 230 by 230 by 250. And there are some very unique advantages to being in a little bit smaller build envelope. Number one is we're able to work around the staff schedule, which is a 24-hour cycle time, including the cool down. So from the time you hit print to the time you're taking parts out of the machine, it's a total of 24 hours. So this is going to guarantee the maximum efficiency of being able to turn over the build platform every single day. And we'll highlight this when we review some of our customers that are using this technology. So these machines have a 60-watt CO2 laser with a 220 degree C processing window. That's going to give you a very wide range of material capabilities. And being open platform, it allows you to use a range of material providers or develop your own material as well. The nice thing also about these machines being open and so capable is that we can actually recycle your waste from your older generation SLS machines or even current multi-jet fusion type technologies. These machines, again, have over 20 plus materials qualified. They are polymer and metal production ready for $100,000. Material changeovers on these machines are really unique in that we can swap materials in under 1 hour, and you can use the same machine for printing polymers that you can running the specialized metal materials, which we'll talk about a bit later. Let's go to the next slide. The QLS 230 is our entry-level machine, but it's big on productivity. It is a 230 by 230 by 230 build envelope. It has the same 1 hour material change capability and also the same 24-hour total cycle time, including the cooling. The 30-watt CO2 laser is going to be able to do a lot of different materials for you. We've qualified over 12 materials on this machine, and it is an open platform. And a lot of our customers really like the value proposition of using this machine to recycle their waste powders from MJF or HB machines. So again, it's polymer or production metal ready from just $69,000. There's nothing in the market that competes at this price point that is production ready, capable of doing so many materials, and yet an open platform system. So moving on to kind of looking at how this could play out in a Nexa 3D factory configuration. Again, what we're talking about with parametric scaling is the ability to scale incrementally, meaning I can start at the lowest price point of $69,000. And then if I want to add more high temperature materials, I can add a QLS 236. If I want to scale in the production environment, I can continue to add platforms or add an 820 and then add carts to double satisfy that productivity across multiple materials. All of these platforms interact beautifully with using the 230 as a sustainability platform for powder recycling. So you can operate the entire production factory for plastics and metals, completely sustainable with zero waste. And this is something that no one else in the market is offering. And I'm really proud to be part of an organization that puts sustainability so high on its list of priorities. So let's look how this plays out at some of our customers. So Jaws Tech, you probably are aware, is a top 5 service bureau in the US. They've been around for quite a while. They started out like many service bureaus with what our term is slow cycle EOS machines with very high waste. And we'll talk about why that is in just a moment, but just stick with me for a moment. Next, they moved to the HP technology multi-jet fusion. This certainly speeds up the printing. The cooling time is still significant, and it also is a waste generator. When you're printing fast and you're only using 10% of your build density, you're going to be generating quite a significant amount of waste. And this was a problem that we wanted to find the solution to, and the QLS 230 are the perfect solution. As you can see, Jaws Tech was able to increase their daily output by taking their waste and running it on these machines for daily output in a fast cycle environment. This gave them 50% output increase while recycling 1,248 kgs of powder in the very first year, saving tens of thousands of dollars in material costs and generated hundreds of thousands of dollars in new incremental revenue by increasing their productivity. So naturally, you start to think, well, what's the payoff? For these 4 machines, essentially a $300,000 investment, they reached break even in 87 days. I'm also very proud to say that they've had these machines in operation for over 1 year, and they have had 0 service calls on these machines. So you're talking about machines that are just really real workhorses for them, that they've been able to turn the waste generated by these slower platforms into productivity and revenue, which is critical. So let's look at this in detail a little bit. Let's look at the results from recycling. That's one of the questions I get most is, yeah, you can recycle, but are the parts good? Actually, the parts are outstanding. And what we found through mechanical testing and from time in the field is that we have complete part interchangeability, which means the parts printed on the QLS with the HP MJF waste powder are equally as good in every aspect as the original HP parts printed with virgin material. The only difference you're going to see is a little discoloration. And this is not due to anything we're doing. This is due to the HP system, which doesn't have an inert environment and actually oxidizes the powder significantly through multiple runs. So eventually the powder gets a little bit off-white, and the thermal optical sensors on the machine for HP don't like that off-white. So it disqualifies the powder and you start to build up waste. That waste is still in very good health and it works perfectly in an SLS machine. So we're able to do that by adjusting parameters, putting that material in our machine, which again, fast cycle, open platform allows us to produce these high quality parts from waste. But it goes beyond just PA12. A very large customer of ours does custom orthotics through additive manufacturing, and they are actually running the HP MJF systems with PA11. So after we proved what we could do with PA12, they reached out and said, hey, can you help us? We've got a lot of waste, but we run PA11. And we did some testing and proved to them that we could produce better quality, finer detail, better edge definition parts with their HP PA11 waste than they could with HP PA11 virgin material. So they again purchased the 236 and started producing parts from waste, turning something that was costing them to dispose of into profitable deliverable parts. So what you see here on the screen is a PA11 part as run with waste powder. You can see it's off-white, it's been oxidized. When it goes through our machine, the parts print beautifully. They then get dyed right along with all the HP parts that come out of the machine, a mottled gray. They get dyed and all the parts go out. Some are from the recycled powder, some are from the fresh powder. They perform equally as well. At the bottom, another incredible case study of a customer of ours, Oakley, who I'm sure you all know. They had they have an HP 580 where they occasionally print color parts, and they wanted to do something about the recycling. One thing you'll notice about the HP PA12 580 specific powder is it is much brighter. HP adds in some whiteners to it to make it accept the color a little bit better in the older 580 machines. And the result is the powder, while it does get disqualified from HP, it is still very usable, and it makes very bright white parts. So you're able to, in this way, give the customer the ability to print bright white parts without any fusing agents and dye those parts any color, very vivid colors. And in fact, the colors are much better than what HP can print on the 580. So again, taking a world famous company like Oakley and turning their waste into dollars is fantastic. They actually bought two of our machines, one specifically for this process, which paid for their other machine, which is being used for softer TPU materials printed on our SLS machine. So obviously what you're seeing here is customers being creative, turning waste into productivity, turning waste into revenue. This is what we're all about here, being able to help people produce more parts with less waste. So next, let's look at what happens when you take waste from your older machines that are single laser, large format SLS printers like QLS or 3D Systems or Farsoon or some of the others. What happens over time with these machines, because they have such long print and cool cycles, the powder rapidly degrades because of the heat exposure. And how that presents itself is when you are printing with powder that starts to get old and it's not very good anymore, you start to get orange peel on the sidewalls or elephant skin, depending on which company is talking about this distortion. And it's really no longer usable on the EOS or 3D Systems closed systems because you don't have the ability to change temperatures as a user because they really just want you to throw the powder in the landfill and buy more. And so what we've done is a lot of customers, as you can imagine, are frustrated by that process of dumping large material in their landfill, or even worse, having to pay someone to come in and take it to the landfill. They've allowed this to stock up. Some customers have tons of the material sitting around the warehouse taking up space. We've been able to say, hey, look, this powder is pretty damaged. So what we need to do to bring it back to life is add a little bit of fresh powder to it, adjust the print parameters slightly, taking into account that mix. And now we can recycle the powder and it's perfectly acceptable. So a mix of 30% fresh with this dead powder from EOS or 3D Systems will clean up the elephant skin and sidewall to a degree to make the parts acceptable for use. So I really want to dig into this a little bit more because I get a lot of questions about why we can do it and why other companies can't. I mean, I think number one is we have the will to do it, and we have expended the research and development dollars to do it for good. So if we look at what's happening with these slow cycle high waste machines, they're long print times, very long cooling cycles, to where you end up with a 20% dense build, but that powder requires a 50% refresh. So as you go through this, you're going to start to develop quite a lot of waste powder with that 50-50 ratio of fresh to new powder. If you look at the MJF, the ratio is a little bit better because our print time is much faster. So we're printing quicker, we're cooling quicker. However, we are still generating about a 30% waste because of the 10% build density that you experience with HP. The nice thing with our fast cycle printers is we can take this waste, again, put it in our machines, or we can print natively with fresh powder. And because our cycle is so much shorter for printing and cooling, we greatly reduce the heat soak time the powder exposure feels. So Even if we're printing with fresh powder, our powder is going to be at a much, much higher reuse rate than these long cycle times you see with SLS or MJF. The interesting thing here is we're running the same density as MJF, 10% in a 24-hour cycle, getting parts out every day, and our powder is significantly healthier because of that short cycle time. So fast cycle zero waste, it's not just a catchy name or moniker. It is a fact about how we operate our machines to the benefit of our customers and to the benefit of their bottom line. So let's dig into the materials a bit. We've talked about sustainable materials, and that's great, but we have most of our customers who also want to run production grade materials for serial production. And obviously, people have the capability to access metals on the same platform is unprecedented. So let's look at that. So number one, the NPK 5000 is a material we're spotlighting today. This is a green material. It's derived from carbon monoxide, and it has outstanding mechanical properties, including ductility and toughness. A yield strength of 51 megapascals, Young's modulus at 1305, elongation of break at 41. Tells you right what you need to know, right? This material is very tough. It's very capable. The other thing about this material that's outstanding is it's not only eco-friendly, but it's petroleum and medical chemical resistant. So these can be used very nicely right out of the machine because they're airtight and they're watertight natively without any type of vapor smoothing required. Now, as you can see, it does vapor smooth beautifully, but it's not a requirement to implement the use of these tanks, use of these as gas tanks or drone fuel tanks or fuel filters or living hinges or low friction applications or just general purpose prototyping. It's a great fit for all of that in serial production. And the fact that it is a naturally green product or derived from a green process just furthers our story and capability here quite a bit. So we're really proud to have the NPK 5000 as a listed material for our machines. Some of our other materials have outstanding capability like PBT, which is a well-known, well-used injection mold material derived from polyester. It's been used in the automotive industry for quite a while for electrical connectors and injection molded production. The machine was developed by Mitsubishi, and it's the same chemistry used in their injection molding material. It has incredible mechanical properties. Pardon me. Has incredible mechanical properties. And then, of course, PA12, the old go-to that everyone's been using for so long, is available along with polypropylene. We also offer PA11 in white or black, another bio-derived material actually developed from castor beans. It has very high ductility and very high impact, a similar material and mechanical properties and performance to PK 5000. Well-known, well-used in the industry, comes in white or black. And then we have some very soft materials like the TPU 75 that we offer, which is a thermoplastic polyurethane with high elasticity and high rebound. Great for the footwear industry, sporting goods, strap, binding equipment, things like that. It's a very, very resilient material for a TPU, and it's also 100% used zero waste. We have TPU 88 in white or black. You might recognize these type of ski goggles. This is a material that our friends at Oakley use, as well as doing their recycling. It's great for lattice work, robotics, grippers, textures, fingers, orthotics. It's very flexible. It can be smoothed easily. It can also be dyed and colored very effectively. So we move on to our higher temp materials. These materials are going to be available on the 820 and, of course, the 236 with the higher wattage of laser and higher temp processing windows. The polyamide 6, well known in the automotive industry. It's airtight, it's liquid tight, great for under the hood applications or serial production. And then PA6 mineral filled takes it to the next level. Adds some rigidity to the part. And then PA11 carbon fiber, a very stiff material, with very good heat deflection, great for motorsports, wind tunnel type applications, and it has a high heat deflection. So if you're one of the many people who've been using Mark Forged Onyx, this material is also a chopped carbon, has better mechanical properties than Mark Forged Onyx for many reasons. But one of the big advantages of using this in an SLS machine is just the productivity versus an FFF machine. We're talking about, one of our machines replacing 20 Mark Forged machines running Onyx. So again, the dynamics and the numbers really favor a tool that's laser based over an extrusion based machine, which is a bit old in the tooth, long in the tooth, I should say. So let's take a look at Nexa 3D in a factory metal configuration. This is something really new and unprecedented. To be able to use these same machines that we use for polymer production, to be able to roll that out and be able to say, hey, you know what? Occasionally I'd like to print a stainless steel part. Can I do that on your $70,000 platform? Absolutely. Within an hour, you can change from PA12 over to a head-made specific powder. And Headmade is the company who owns the patent and produces the powder. And we'll talk about how it works in a minute. But again, you're able to change those powders very effectively. And if you wanted to do a small steel setup with M2 or 316 or 17.4, you could easily do that for not a lot of money by adding a chemical debinder and a furnace capable of processing steel. Obviously, if you want to go into metals in a big way, into high production, there are lots of options for that with larger pieces of equipment that can be more automated and handle more pieces in the furnace. So digging into this a little bit more, let's talk about how people are using these machines and metal technology to achieve excellent results. So I just put together this example to really show a real world application. As we get into more electrically powered vehicles as part of a sustainable approach to our daily lives, we're going to want to lighten all of our parts without giving up safety. And so in the engineering world, we have a term called factor of safety that I'm sure most of you are aware of. And this is basically your design criteria for a part to make sure at a certain factor of safety, you have the safety required for your assemblies and mechanisms and things of that nature. So using the tools that have been available for quite some time, like FEA and CAD, we can account for our factor of safety by doing analysis based on the geometry and also the mechanical properties of the material we're using. So for a lot of reasons, if we could move to titanium, we don't lose any strength that we get out of steel, but we certainly make the parts much, much lighter, but just as safe and just as effective, which the lightening of the parts and the mass reduction really, really are huge advantages for electrical vehicles for obvious reasons. So let's move forward and see how we do this. So with titanium, for example, using the head-made cold metal fusion QLS process, we're going to print with titanium, and we're going to sinter after the fact, which I'll show all of that in great detail in a moment. The beauty of the way this system works is we have uniform shrink in all axis of about 13% for titanium, which is outstanding. The other beautiful thing is we're going to be able to do thicker, chunkier parts than we would ever want to do with DMLS. So we can get up to 30 millimeter wall thickness or down to 1 millimeter wall thickness in some cases, and still produce parts that are 97.5% dense and have better mechanical properties than billet machining. You say, well, how is that possible? Well, with this system, we're using more pure feedstock than what is used when you form a round bar or a billet slab to machine. So we're starting ahead of the game in terms of the mechanical properties of the material we're working with versus machining that metal. So the way we implement that is very simple. We actually take the mechanical properties of the sintered part, which you can see here. We have better yield strength, better ultimate tensile strength, and better total elongation. We feed that data set into our FEA software, and then the result is we're going to get a part that uses less mass versus a machine part, even if we're comparing the same material. So if we were machining titanium, we're able to make a lighter part through this process than we could with titanium and retain the same factor of safety. So it's a really exciting solution that our customers are taking advantage of already with the QLS 230. The nice thing also being having the term cold metal fusion associated with it gives you the idea that we're sintering at very low temperature because we're only sintering the polymer backbone, not the metal. This allows that powder to be 100% reusable. So looking here at the steel offerings that we have, 316, 17.4, and M2, these are materials that are going to be used in industries for tooling, for valves, for medical devices, for lightweighting, generative design, you name it, steel is a go-to because it is so strong and capable. So again, uniform shrinkage and all axis, that's going to make sure that our accuracy is where we want it to be. And we're not going to have huge issues with warping or twisting or things like that other technologies like binder jet experience. So again, let's take a look at now how the process works. So with a QLS Nexa factory process, you're able to select any of the machines to run any of the metal materials. And if we take a look at how this plays out, we're printing in the 230 here with steel, M2 tool steel in this case, and we're able to do the full print. There's no issues with stacking or nesting like you would have with binder jet, which would create some differential shrink. We're able to get uniform accuracy throughout the entire build. And all of the powder surrounding the part is 100% reuse because we're sintering it at very low temperature. Once the prints are complete, we take what we call green parts out of the machine. They go through a chemical debind, which the chemical debind will remove part of the polymer backbone and create micro cavities in the part. Those microcavities are crucial in the next phase of the sinter furnace because as that metal expands, there's room for the metal to expand within the part without creating distortion and twisting. So the result is we get very accurate production parts with very high degree of mechanical density and very high as related to CNC machining mechanical properties. Also, of course, no supports, and we're working in a zero waste in the solution. So fantastic. So let's look at one of our current customers using a QLS 230 with M2 tool steel to provide revolutionary designs for their customers. So Utilis is a tool holding company, a traditional CNC machining company. And I just love the tie-in here back to traditional CNC machining. We're taking a tool holder for a CNC machine, creating a CAD design that includes internal conformal cooling channels to drive the coolant right to the cutting insert, which you see here. The benefit of this is aiming the coolant right to the cutting surface is going to make these inserts last twice as long as they would without the directive cooling that you see here. And you take a look at the finished part, you can see it's about a 2 millimeter channel running all through the part that is able to flow the coolant right to where you need it. And that was done with analysis, of course. So this is a full production part from Utilis. You can go and you can buy one of these. They're made from beginning to end. The printing is done on the QLS 230. Okay, so just some basics about how our machines work and installation. The smaller machines, they run on single phase 220. They're going to be placed in a climate controlled environment. We require a nitrogen membrane system, which has no actual moving parts. It uses osmosis to change compressed air over to pure nitrogen, and that supplies the inert build chamber that allows us to do a lot of the things we do so effectively. We're going to use an explosion-proof vacuum, and then we offer a powder recycling station for breakout, sieving, and mixing. And then a blast cabinet, which is typical of the SLS process, would also be something you would want to get. So looking at our post-processing, we have a very simple solution for the 236. The nice thing about this unit, unlike some of the other smaller SLS machines in the market, it's not built into our system. And so what that means is this system, while it's highly effective, will never interrupt your printing. So you're able to print, put your build cake here, let it cool down for 2 hours, restart the machine. If something happens with this, which is unlikely because it's a very simple system, it will never affect your printing. And that's just not the case for systems like MJF from HP or the Fuse One that have integrated sifting and mixing. You're adding a lot of complexity without a ton of benefit, because if your sifter goes down, you can't print. With this technology, you never have to worry about it. We use a motorized sieve. They break out in this area in a negative pressure environment, which keeps the powder in. We sieve through the mechanical sift. We go into the collection bucket. And with our collection bucket, we can prescribe the mix ratio from the start. So we don't have to take it out and then remix it. We can do everything in bucket and transfer it back to the machine. Very simple, very easy, but highly effective. So let's look at some pricing here. So if we just think about, hey, I want to get into metals, I want to get a machine and I want to run steels, you can do that for $250,000, which is significantly less than if you went with even a lower performing binder jet system like Markforged or Desktop Metal. The printer alone for the Desktop Metal is going to start at $200,000. That doesn't account for software and furnaces and all these things. You're going to be well over $300,000 or $400,000 when you get all done, and you're not going to get the same print quality as you get here. The zero waste plastics production kit, obviously we can go into full production, lights out manufacturing with this system, working in a zero waste environment, working with 2 zero waste materials. With PA12, we can recycle here on the 230. TPU is 100% reuse. So just a good example of doing serial production with zero waste. Next is going to be our production plastic and metal kit. Thinking about putting all of this together under one roof, we can certainly help with that. PA12, TPU, recycling, steel production, 316, M2, 17.4, all under one roof for $849,000. Very, very versatile system. I can use any of this system anyway. I can run metal over here. I can run TPU here. I can do production plastics here. You've just got a whole array of options with our systems. So let's talk about what our customers say. This is what makes me more proud to be with this technology for 5 years than anything, is that our customers come back and buy more machines. So TriSite is a medical device company that had been using FFF. They studied everything in the market. They come to the 230 and said, hey, this is interesting. We think this could be a fit. 90 days later, they came back and said, hey, the machine's already paid for itself. We need to buy more. They now have 4 in-house systems doing full production. Other customers like Service Bureau, 3D Printing Tech, started with 1 machine. It proved to be so dependable, so reliable, they added 5 more, and they have a total of 6 machines now. Jaws Tech, again, they have changed their business completely, very dynamically. They paid for all their machines in under 90 days. They now have 4 machines and are looking to add more metal capability going forward. So let's just look at our customers, and I think you'll see something unique here, is that small companies, large companies, international companies, they're selecting our technology, and these people have the option to buy any technology at any price, but they're buying because our story is different, our capabilities are different, we're able to circumvent the cost of having waste and having the waste removed. We're just able to be better in so many ways for them that really work. That's the thing that makes us happy here is finding solutions for customers like Oakley and BMW and Nike and Volkswagen and the biggest service bureaus in the world, like Xometry, like Quick Parts, like Jawstep. We're able to do it even with educational customers like New Mexico State, Rochester Institute of Technology. These customers are looking for something unique, the ability to develop their own materials, be dynamic within their printing organization, and we offer that to them. I want to thank you very much for joining us. We're going to open it up for questions at this time. So thank you very much, and please reach out to us as we go forward. We'd love to talk to you about your sustainability path.
Thanks, John, so much. Let's go ahead and jump into the questions. We've got some great ones coming through. To start off, we had an attendee asked, can you use polymer and metal powder in both the 230 and 236?
Absolutely. The metal powder is polymer coated. It's from a company called Headmade, and that makes it very easy. The material changeover takes about 1 hour in the machine. If you are going to use materials frequently, then you change materials frequently. What I would suggest is getting 2 processing stations, because that's where there's a little bit more involved cleaning required. But in the machine, materials changeovers take less than 1 hour.
Okay, great, thank you. And we got another fast follow on a materials question. This was in reference to the PK5000. He said, when you say the material is airtight, to what degree? Is it airtight under atmospheric pressure, or has it been tested under vacuum or overpressure?
It has been tested on all 3. I would refer you to the manufacturer's data as to the depth of testing.
Okay, great, thank you. And then back to the metal powder here. How does the cost of polymer coated metal powder compare with the typical metal powder you would use in, let's say, like a DMLS machine?
It's very competitive, and actually the polymer coated powder have been really optimized price versus CNC machining. Now, if you're comparing it to DMLS processes, they're really going to be different applications. So the Headmade QLS process is going to be targeting larger geometries with thicker wall thicknesses up to 30 millimeters. And generally, we don't see those type of geometries being printed very much on DMLS. DMLS typically is going to be for lattice work, highly detailed, smaller parts, and thinner wall geometries.
Okay, great. And now we'll dive into some questions around the HP recyclability for that powder. What percentage fresh material do you need to add to the used HP material?
You don't have to add any. The powder is quite healthy. The examples I've shown have been printed with 100% recycled powder. The only time I would say that a customer might want to add fresh powder is if they want to produce really, really bright white parts. As I stated, the HP powder gets oxidized through their process. So if you want to whiten the powder, you could add some fresh, but it's not a requirement by any stretch.
Okay, great, thank you. That's interesting. And then continuing down that path on recyclable MJF powder or HP powder, do you have to pre-process the powder in any way? Is it just sieving and it's ready to go, or are there more steps that need to take place?
Yeah, there's no steps required. So we generally, take the powder that we receive, that we've tested in the past, right out of the bag, put it in the machine and print. I think the HP machines do a pretty good job of sieving and everything automatically. So once we receive that powder, it's generally ready to put in the machine and go.
Okay, great, thank you. And what quality measures are necessary for defining MJF waste powder as good for QLS? It looks like this respondent in particular says their MJF powder is pretty oxidized.
Yeah, I mean, so it's going to vary from customer to customer, the state of the powder. But we have printed with powder that was almost brown with no problems. It really varies on how you use your HP machine. A lot of HP users will typically run at 10% density or much less, depending on their geometry. And generally speaking, when you're running at 10% density or less, the health of your powder as it gets rejected by the HP system is very good, and it's not overly oxidized. We've seen customers who said, yeah, we've kind of gone around the system and dumped powder back in through the top of the feed and done some things, and their powder gets a little more oxidized. Or you're running very heavy, very dense builds, and the print times are longer and the exposure times are longer. But generally, every powder we've tried from a customer, regardless of color or oxidization, we get great looking parts right out of the machine.
Awesome, thank you. And then looks like we have, I believe you may have answered this, but let's go ahead and re-emphasize just in case. But for that recycled HP powder, are there any compromises that you need to make? In other words, how does it affect mechanical properties, aesthetics, and dimensional performance?
Yeah, so we've studied this in detail. We've done independent testing with tensile bar test by some of our customers, and their feedback to us was it was within the margin of error of testing mechanically HP parts throughout a build. So they didn't see any real difference. I would say it's going to be within 3 to 5% mechanically of a standard HP part, printing it in a recycled format. You certainly are welcome to test, but I think you won't see anything from the naked eye in terms of print quality that would throw you off. Most people who see our HP parts can't tell the difference in terms of print quality to our standard SLS quality with fresh powder.
Awesome, thank you. Jumping into our next category of questions, there's a lot of questions about the systems themselves. It looks like we could answer a few of those questions just by reviewing kind of the bundle pricing again for each of the items. There's interest in the cost of the printers as well as the washing or debinding and sintering station for the metals. And there's also an interest in understanding what's the cost of the breakout station, and do they need the breakout station or can they use their own?
Yeah, so first off, I'll take the easiest one. You can certainly use whatever breakout equipment you already have. Again, you just want to be careful of, mixing powders and breakout stations, because those are a little bit more difficult to clean out, the hoses and things like that. But if you already have a breakout station, I'm sure you understand that. So with regard to our equipment pricing, the 230 is $70,000 US. And so if we wanted to do a production steels kit, that's going to give us a small debinding system and a small metal furnace that's capable of doing steels. So all in for the machine, the metal debind and the sintering furnace, you're going to be at about $249,000, with the furnace being about 125 of that, and the debinding oven, if you're looking for automated debinding, is going to be around 50,000.
Okay, great. And then what about the package pricing for the polymers?
So if you're looking at doing PA12 or TPUs, that type of recycling, around 600,000 would include the QLS 820, an additional cart, and a QLS 230 machine, where you could run recycling of all your PA12 powders, or you could use it for another material at any time, of course.
Okay, great. And then what is the individual pricing of the 236 and the breakout station?
Yeah, so the 236 is 99,000. The Easy Clean Pro that we offer is 14.9.
Okay, great. Awesome. All right, jumping into, we have a lot of questions coming through, so this is fantastic.
Great.
Let me look through, try to categorize them as best as we can. Okay. Okay, going kind of back to powder recyclability, we had a few more questions coming in.
Sure.
The first is speaking, they don't emphasize whether it's HP recycled powder or just starting with, fresh virgin powder, but it says, what's the best practice for powder refresh rate utilizing the QLS 230 for subsequent runs. So it sounds like
Got it.
they dye their parts, so they're not necessarily worried about the color, but more worried about mechanical performance and things like that.
Yeah, so the PA12 that you get out of the machine from HP is very healthy. So if you're printing, let's say, a 15% or 12% dense build and you extract those parts, if you simply replace that powder removed with, say, 20% more of the HP recycled powder, you're going to be able to print a significant number of parts depending on your starting powder health. Generally, this is what people do. They will run the HP powder, they pull out, let's say, 10 or 20% of their build volume in parts, they replace that with, say, 20% of the recycled HP powder, they continue to print. You can always add more of this quote unquote free powder if you want to change your ratios or improve the ratios between the HP waste that's been ran through the machine or the HP waste that you have on hand. So it's really dependent on what you're looking to achieve and the starting point for your powder. So it's really impossible to give you the best practice. All I can say is this is very effective in using up all of your HP waste.
Great, thank you, John. Continuing on, there is a question regarding part density for recycled parts. Are you seeing any differences in the density of the parts
We
based
are
off of fresh versus recycled?
we are not. This has been backed up by mechanical testing, and we're not seeing significant differences in parts. From one to the other. I mean, this is what I mean by part interchangeability. The parts that are coming out of the QLS 230 with recycled powder are performing equally as well as average HP parts coming out of the MJF systems.
Okay. And then just a few more questions coming in. I would say, to our attendees, if you have anything else you want to get in, please do so now. We've got 3 questions left here. What laser focus and layer thickness are used on the 230, the 236, and the 820?
Yeah, so we're typically quoting all of these print times at 0.1 millimeter. All of our lasers have standard kind of industry spot sizes. I get that question a lot, and I'm sometimes puzzled why, because there isn't a 100% direct correlation between laser spot size and part quality or part accuracy. We often see the 230 outperforming machines 10 times its cost with a slightly smaller spot size, because when you have a bigger build volume, the optics are a little bit more distorted out at the edges. The smaller build size is really key for high print quality, and then how your laser interacts with your software is also crucial to print size or print quality, more so than just the raw data of the laser spot size.
Okay, so yeah, sounds like it's really helping with the quality, accuracy, and detail there.
Sure.
Awesome. Okay, just a few more coming in here. Before jumping, we've got more metal questions coming in here, so I'll ask one last polymer question. Can powder be refreshed indefinitely, or is there a point where it just won't work anymore?
I think what we've seen, I can't answer that question in terms of forever, because obviously we haven't got there with forever, but what we are seeing is the ability to refresh the powder in combination with parameter control to get high quality parts. So I can't say it goes on and on forever, but what I can say is that our customers are taking powder that they're paying someone to haul away and put in a landfill and making parts with it today. And that's what's important, is what people are doing with this technology today from a profitability and sustainability standpoint.
Okay. And then what about installation? Are there any requirements for installation, such as extraction lines, pressure, etc.?
Yeah, so for our 230 and 236 platforms, the machines require single phase 220 to operate with about a 32 amp service. You would also need to provide shop air. which most shops have that are running SLS machines today. And we will also point you to selecting a nitrogen membrane, which can run 1, 2, or 4 machines, depending on the size, which basically just is a box that converts your shop air into pure nitrogen for the machines.
Great, thanks, Sean. All right, jumping into the last few metals questions, and then we will wrap up. Do you have any US-based companies that can do the debinding and sintering of the metal parts?
Yes, we have companies in North America who are actually sintering and debinding with metal parts, and we have material that we're actually printing on our machines in California.
Great, thank you. And if QLS polymer-coated metal powder offers larger parts than MEM-derived binding printers, is there software to assist with shrinkage adjustment of part designs? And is there a path to doing larger parts outside of the limits of the 236 currently?
Yeah, you can actually run this powder on the 820 and print parts as big as 350 by 350 by 400. The beauty of this system and the beauty of having uniform shrink is that we don't need a lot of software to manipulate the geometry to try and account for shrink that isn't uniform. We simply scale the part by the shrink factor and print the part, and we're ready to go. It's that easy. Now, there does need to be some minimal kind of design intelligence, obviously. But as you can see from the parts that we're showing here, we're able to do a lot of very difficult geometries in a high precision way that just aren't really available when you use binder jetting technologies. For instance, our ability to stack and nest parts do not affect Z shrink, which is something problematic for binder jet systems. When you start stacking, you end up with shrink differentiation all over the build, and you really have to rely on some algorithm or something to help you kind of fix that. Those inherent problems to binder jet are not present in SLS. The beauty of this system is that it was designed from the back end to the front, where they went with a tried and true MEM style process that's been around for decades, and said, okay, what if we figure out how to print MEM parts on a SLS machine, rather than some of the people in the industry who started with a 3D printer and said, hey, let's figure out how we can print metal and use software, algorithms, and special fancy ovens to try and make things work. This is done the opposite way. We're using tried and true technology from MEM. We're simply printing those MEM parts on an SLS machine.
Awesome. We had our last question here, and then we'll wrap up for the day. What are the features of the EasyClean Pro breakout station? Is it manual or automated depowdering? Does it do mixing of powder? Does it do sifting, etc.?
Yeah, great question. So the EasyClean Pro is a very simple machine. It has negative pressure via your explosion-proof vacuum for breakout. So you're going to do manual breakout. The powder is going to flow into this motorized sieve with interchangeable screens, depending on the powder you're using. So it will sieve the powder, it will collect in this bucket. So basically, if we're doing let's say we're printing with a material, we want to do an 80-20 refresh. We start with 20% fresh in our bucket. We sieve to the 100% line, and then we can do in-bucket mixing with something like a cordless drill, or you can mix with just the lid on in a different way, a shaker. And then the powder is just transferred back to the machine. Again, it's the goal we're going for here is automated to the degree that it can never impact your print. The worst thing that can happen in a production environment is if this piece of equipment impacts printing. And I believe our competitors from the low end all the way to the high end, if they have an extremely automated system, the sifter can impact your printing if the sifting stops working. And we wanted to go for something much more simple, but highly effective that captured the ability to break out mechanically and automatically sift and mix in the same bucket.
Awesome, thanks. I think that was a really thorough explanation. So I think with that, that really closes out the Q&A portion of the presentation. I wanted to thank everyone for attending and spending time with us today. As you know, powder bed fusion processes like this, and certainly the subject of sustainability is rather in-depth. Would love to continue the conversation with you. So feel free to reach out. This recording will be made available within about 3 business days after the close of this live webinar. And so you feel free to share it with friends or rewatch at your leisure. And again, can always reach out to either myself or John to discuss this further. But thank you so much for attending, and I hope you have a great rest of the week.